Guys, so last class we learned about classes. So now today let's learn about unified types. Right, I just created a class, right, and with getters and setters. Now let's go back to our sample main. Okay, so it's too clumsy. What I'm doing is I'll just move all this data I just define a sample method. I'll just call it as like for testing and let's move this entire stuff over here. Right, so if at all you want to do something over here, so we could still write it. Or else in main, yeah, come back. Now let's learn about unified types. So in case of unified types, this is the hierarchy in which the object work. Right, double, float, long, int, shorts, all these primitives are kind of, it sets the value nothing as a default, or if the value is blank, then it actually sets it to nothing means no memory is kind of allocated to that particular variable, right? And it everything gets inherited from any val, which in turn will get inherited from any. So same thing for all these class variables. Let us see your class, list, option. So all these things, they are kind of inherited from any ref, and in turn like it actually comes from any. Okay, so let's try it out how it actually works. Now let's create two variables. So let us say x of type int, right, is equal to 0, um, where y of y, which is double, right? Sorry, it should be caps. So double, right, which is equal to 15, and where c, which is a character variable, and its value is equal to, say, k. Right, now when you could what you can do is let's create another variable. So d here, right, I'm specifying that it is, I can assign any val to it. Now let us see. Good. So I will be able to assign x, or either I will be able to assign y, and I will be able to assign c. Since all these variables are kind of extended from any val, so for any val I can set any of these variable types, right? Same thing we can do for, let us try doing it for any reference, right? As you could see, so list is one of the things. So let's try creating list of say integers, right? So one interesting thing is I can initialize this particular list to null, right? And let us try creating our unified types. Unified types, which is of type unified types, is equal to new unified types, right? So whenever I do it, now let us create another variable, sample ref. Okay, so let's call it as any ref. As you could see, I can assign it to my list, or even I can assign it to unified types. Let us try doing it the other way around. Let us say if I wanted x and c, As you could see, the any reference, because what it does is it actually unboxes this particular value and it can actually set the things. Right, so now let us try doing it in the other way around. Now let's move all these things. I'll tell you about boxing and unboxing later. Okay, sample any ref and sample anywhere. Let us try creating my list. So now it is throwing an error, does not expect of type anywhere. So whenever, this is one interesting thing, so whenever you wanna assign the value to C, then any primitives, any val would actually take, but it will not take any references. But any reference is kind of a typical one. It will take all the references, and it would even take unified types, which is a class, and it can even take Y. Now let us see what will happen to Y. Let's write some println testing unified types. Right? Let's put a debugger here. Let's play it. Yeah, see what it is throwing is, though it is not throwing at the runtime, sorry, at the compile time, but it is throwing error stating that it is required any ref but found double, which is of type any val. So all you need is at compile time it is throwing an error. So now let us try putting our unified types and let's run it. Yep, it's working fine. So that's all, guys. So all these classes, lists, or so list is again a type of a class. So that's why it is, you can use any reference for it, and any val is something that you could assign any of these values. Now let us try creating any type. So where say sample any. So the interesting part over here is you could assign, yeah, so when I just put it as any, then I will be able to assign yeah, unified types as well as where sample any val, okay, of type any, and I can assign D. See if it throws any error. Nope, it doesn't. And if you see the values of it, um, the sample any, it is taking all these values, and sample any val it is taking, which is value k of value set 75. So uh, by default, guys, it's a character variable, that is why it is showing k, and 75 is the ASCII code for this character variable, so that's why it's showing 75. Right, so this is it, guys. Like, this is how the inheritance work over here. You can initialize any of these things with null value. By default, when a memory is kind of not occupied for any of the val types, then it would actually come as nothing. Okay, so let's stop it. Let's go back and let us see. So this is how the typical hierarchy works. Okay, now let's learn about implicit typecasting. So when you do implicit typecasting, make sure like this is the flow. So byte is like the smallest form of integer, and short, it takes only 1 byte memory, and short is like 2 bytes memory, int 4 byte memory, and long 8 byte memory, and goes on. So as you could see, you can implicitly convert a long to float and float to double, and byte to short, short to int, as the memory is increasing from a byte to double. So this is what it happens. Like, you can explicitly typecast one to another, but you will not do it in the other way around. Okay, so let us see how it what exactly it means. Now I just initialized a value x, right, and I initialized value y. All I can do is I can write y is equal to x, right? It still, as you could see, so when I try setting the value y of x, it still works fine because double is having like higher authenticity in compared to integer. So now let's try doing it the other way around. See if I could actually do it. Yep, it is throwing an error which states that changing type to int is kind of not implicit. So that's what it says over here. So it goes like when we do the typecasting, it allows only one side, but it will not allow the another side. Okay, so as I said, so we learned about typecasting and we learned about like implicit typecasting. I will not call it as typecasting. We will deal with typecastings later. And yeah, so the basic inheritance of any val and any ref and any, right? So that's all for this sessions. Let's move on to other things later.